So what we're talking about is modern blockchain architecture starts from the bottom and then works up to build solutions, as opposed to most blockchain projects, which will start at the top and then realize, oh, we've forgotten digital identity and we've forgotten cybersecurity. Let's add it into the system and then work down. So a very fundamental question in cybersecurity is, how do I get data from point A here to point B when I'm going through some nebulous cloud C? And this cloud, I don't know what's inside this cloud. It can be Amazon Web Services. It can be web servers. It can be routers. It can be IoT devices, what have you. Very simple question, right? We've for sure solved this problem many, many years ago. However, there's a problem with this question. The main problem is that it's not really fully solved. And the current architectures that many companies use are making this problem much, much more difficult to solve as time goes on. So the problem that we face here is that, I'm sure you guys have seen with your companies, you're moving more of your data to the cloud. You're using different types of infrastructure, microservices, web services, mobile devices, IoT devices. And that poses a new type of problem for companies. Number one, it's an operational risk because companies cannot secure the data if they don't understand what device is actually transmitting the data. Okay. And as infrastructure becomes more diverse, what happens is that we get a situation where you have a few parties in this cloud that you can't control. More importantly, the service providers that, let's say, a bank uses. Let's say a bank uses Amazon Cloud. You use a cloud provider, you use a network provider, you use certificate authorities. However, to banking infrastructure, those services accept basically zero liability to the client in the event cybersecurity is broken. The case in point, just a few months ago, Capital Bank in America had their data hacked because a former Amazon employee posted the credentials on the internet. Now the question is Amazon liable to Capital Bank for that? And the answer is no, they're not. They can't accept liability, and so therefore banks have, particularly banks and other critical systems, they have a operational risk because they're entrusting cybersecurity to some organizations that have zero liability to them. The point I'm making here is that a new data security infrastructure is needed in order to meet the trends of how banks, enterprises, and industries are using data and cloud services and other services. And this is what we're going to talk about today. So let me introduce you this concept of a modern blockchain architecture. Okay. The focus here is to not specifically smart contracts or to exchange some cryptocurrency between one party to the other. The focus here is to solve real problems for finance, enterprise, and industry. And there's a very specific set of attributes that this architecture has. Number one, it is focused on what we call data provenance. This is another word for data security, but with a little additional features. Data provenance means, can we control who accesses data? Do we know who's created a piece of data? And do we know the lineage of the data, the history of that data that passes through our infrastructure? That's called data provenance. And this is the key problem that a modern blockchain architecture sets out to solve. Because once you solve that problem, many, many benefits flow from that. The second attribute is that a modern blockchain architecture tries to integrate with existing systems, as opposed to asking the users to migrate their logic over into a blockchain architecture. And I'm speaking specifically about smart contract systems. And I'm sure you guys have researched some of this as well. It's very problematic to ask a bank to migrate their post-trade processing systems over to the Ethereum blockchain, because you also have to migrate the logic over. A modern blockchain architecture does not do that. It goes the opposite direction. And finally, a modern blockchain architecture is really not specific on any blockchain, but it's a hybrid. It uses whatever works. So I'm going to present to you a hybrid blockchain distributed ledger, DLT architecture that we use within Keychain. Okay, so if anything you guys remember about this part of the presentation, it's this. What I'm talking about with doing with blockchain architecture, this modern architecture, is to focus on the part of this iceberg, which is the vast mass of the iceberg itself. You focus on this first, and then the small piece here really represents all the workflows, contracts, and digital assets that we actually see. You think of like Bitcoin and some value transfer. But here is the big problem. Okay, so what we're talking about is a modern blockchain architecture starts from the bottom and then works up to build solutions, as opposed to most blockchain projects, which will start at the top and then realize, oh, we've forgotten digital identity and we've forgotten cybersecurity. Let's add it into the system and then work down. Okay, that's the key insight that we're talking about here with the modern blockchain architecture. Okay, so I'm talking about a layered approach, and this is sort of the architecture that really defines this modern blockchain architecture, or MBA. At the very base layer, we, Keychain, are using a blockchain-based identity. It's not really a digital identity, but rather a cryptographic identity, but it's a fine point here. Then, based on that blockchain-based identity, we then implement a layer 2, which provides data provenance, data security. And that provides security of data wherever the data flows, wherever it rests, whether it's on a PC or a server, on an IoT device, or on a very insecure network. We secure that data both ways. Okay, sorry. There's a middleware, and then, if necessary, there's a distributed ledger for things like asset transfer. Okay. So if you take that approach, data provenance and a layered approach, this is what comes out. With respect to cybersecurity, the users, the participants of the system, reclaim agency over their data. They reclaim ownership. They reclaim agency over their digital identity. So even if Amazon does get hacked, the Capital One data is encrypted in such a way that only Capital One can decrypt it, not Amazon, and therefore they protect themselves. It's data-centric security, as I mentioned. So the data can flow anywhere in the network, outside the network, on your devices, outside your devices, and it maintains the same level of security. And it's more scalable because the current certificate authority system is very much based on a human-centric KYC process, and it doesn't scale to the tens of billions of IoT devices that are going to come online within the next few years.
ここで少しQ&A がもしあればですね、いただきたいと思いますと。内容としては、ベーシックはモダンブロックチェーンアーキテクチャという考え方についてご説明をさせていただきました。で、第一レイヤーにブロックチェーンを使っているというのが当社の一つ目のレイヤーでございまして、ファーストレイヤーがブロックチェーンですと。で、ここがいろんなブロックチェーン使えるということと、今はもうビットコインベースですので、ビットコインでも使えますよ。もうすでに使える技術ですよというところですね。実用化できます。で、その上にセカンドレイヤーでデータプロベナンスのレイヤーとして、もうデータの証跡っていうか、改ざん体制とか暗号化っていうので、このデータの整合性っていうのをきちんと 捕まえましょうというのがセカンドレイヤーです。その上にミドルウェアを提供することで、既存のエグジスティングシステムとご一緒に統合することが、明日からよりも作業ができるという環境をご提供し、さらにその4レイヤーで、さらに DLT、社内だけとかメンバーだけで使える DLT を提供します。で、その DLT には何が書けるかっていうと、デジタルアセット、コインみたいなのも、中央銀行さんとか企業さんが発行することもできるし、別にエネルギーのレジャーであってもいいし、どんな使い方でもできますよ。したがって、いろんなインダストリーさんでこういう、ミドルウェアを使って開発ができるんではないかというのが、モダンブロックチェーンアーキテクチャの考え方です。というご紹介でございました。はい。ここまででも多分、普通のブロックチェーンは第一レイヤーとは、セカンドがライトニングとかっていう話だと思うので、だいぶコンセプトが違うので、ご質問とかあれば、ここでお受けしますが、どうですか？どうぞ。
デジタルアセットっていう話ですけれども、これはいわゆる最近流行りのセキュリティトークンみたいなそういうのも含めて実装できるようなものになるんでしょうか。
So digital asset layer treat security tokens or non-fungible tokens well, right?
That's right. Fungible and non-fungible tokens are capable to be implemented with the digital asset layer based on data provenance.
ベースにデータプロベナンスのレイヤーがあるので、この4層目の DLT のところでは、セキュリティトークンも扱えますし、ノンファジブルトークンといいまして、ゲームのアイテムみたいなもの、だからそのお金みたいに分割できないものでも取り扱うことができるようになっています。